Hello, and welcome to the 6-5 Summit. I'm Shelley Kramer, one of the founding partners of Futurum Research, and on behalf of my team here at Futurum and the team at Moor Insights and Strategy, welcome. We're glad to have you. In this spotlight session, Moor Insights' Patrick Moorhead sits down with Simon Segars, the CEO of Arm, and Jensen Huang, the founder and the CEO of Nvidia. Their conversation revolves around the impact of Nvidia's potential acquisition of Arm across global markets, as well as how it might impact the development of future technology. There are exciting times ahead, and this is a timely and interesting conversation that I am certain you won't want to miss. Let's go hear what they have to say.
Simon and Jensen, thank you so much for coming on the 6-5 Summit 2021, Day 3. I think it's going to be great, and I've been looking forward to this for a lot of time.
It's great to be here.
Great to be here.
Here we are in 2021, where first off, semiconductors have adopted a lot of software, but also when you combine software, semiconductors, and the cloud, the real magic has happened. And that's what I've seen, and I think you're probably seeing that as well. But where I'd love to start, because the two of you are in some really interesting places running two very successful companies, what is one of the biggest things outside of Nvidia and Arm that you see happening out there today?
I would say that in the world of computing, the single most dramatic change is how software is developed and deployed. It used to be the case that lots of engineers got together, amazing craft, we developed the software, we get it tested to the best we can, and we shrink wrap it into a retail box, we put it on retail, and then we update it again once every 3 to 5 years. But the way that software is developed now, and the magical things that it can do, machine learning and these large computers are augmenting the software engineers, and they're learning from data, and they're creating magic software. We call it artificial intelligence. And the thing that is really quite different about this new type of software is that the entire workflow from the development of the software, the collection of the data, the training of the models, the deployment of the service, and then collecting new data, which then trains the model again, that entire loop is continuous.
So software creating software.
Software creating software. Software is never finished. Software is continuously changing. As a result, the world can't have these systems with all these specific chips that are rather fixed function, but the world wanted to be software defined. Right. So this whole concept about the world being software defined, machine learning, artificial intelligence, cloud computing, it all kind of goes together.
Well, in both of your respective businesses, you're investing a tremendous amount into software already. And Simon, I think the same thing is true for Arm, but what is super exciting that you see in the next 5 years?
Well, I think when we look out, the number of end markets that are creating the pull on all of these technologies simultaneously. So when we've been through growth phases of the industry before, it's generally been a market that's been driving it. But at the moment, it's like multiple markets. You've got cellular going, with the rollout of 5G, which is really as a foundation for lots more stuff to come. And then people are starting to talk about the development of 6G. You've got digitization of every part of our lives, which has been accelerated by the experience of the last year. You've got things like electrification of transportation. All these things are happening at the same time, which is just creating enormous demand on the technology industry to get behind it and create solutions. And building on something Jensen said a moment ago about how we used to package stuff up and it went into retail and kind of that was it. Now these things have a lifetime where the cycle is elongated. So a product isn't just sold, used, thrown away, you get the next one. So many things are turning into a service, and that changes the way you think about design as well.
Yeah, I'm really excited about the fungibility of compute, and whether it's the deep edge, the far edge, the middle edge, the edge, the data center, and the ability to do the processing at the right place, which is typically at the point where a lot of times the data is ingested, and the ability for that to have an impact on society. When I think about the point that we do get to L4, L5 out there, and that just fundamentally, that changes everything. I see companies, and I talk with folks who are being able to manage a 100-story commercial building with their smartphone, okay? Pulling together IT and OT in really intelligent ways and actually saving power.
The two fundamental dynamics that Simon and I just mentioned enabled all that. Yeah. The fact of the matter is, because you can now have these microscopic computing devices that are at the edge, the fact that the software is not written as a packaged software that's dropped on that device, but is orchestrated out to that device over a network, run like a service. It is possible on one pane of glass, the cell phone or a PC or whatever, one pane of glass, to be able to orchestrate millions of devices out in the world. And that's the future. That's how computing is going to get developed.
And it isn't that the software just moved from one place to another. The software that delivers the application is running in multiple places at once and interacting with other pieces of software running on, in a completely different infrastructure. And that's fascinating, I think. It's really hard to manage, but I think what you can produce with that is really fascinating.
Yeah, and with containers gives you the ability to run, let's say you're at the deep edge, and that capability is too much for it. It automatically, there are frameworks that will now bump it up to the next level. It might add some latency, but it magically does this. So literally from your smartwatch or your smartphone, you have an endless supply of opportunity. And that computing is done in the big cloud all the way down there, and I think that's great. So speaking of big things, the biggest news in semiconductors was and is the potential deal between ARM and Nvidia. I know there's a lot of questions, though, and having the two of you say it is the most important way to do this. And I think the first is, why is this good for ARM customers? And maybe Simon will...
I like the way Simon says it, because he says everything nicely.
Well, those trends we were just talking about, more computing is needed in more different forms, running more software, much more complex frameworks, and the end applications are limitless. So right now we're looking at everything we could do in a day. We've just got way more to do than we've got people to do it. That's kind of always been the case, but right now it's more so than ever. And as I think about the future, it's more so than ever. The range of products that our licensees want to build is growing and growing. What they're asking from us is increasing and increasing because of the complexity going up. And there's no way that we can do that on our own. So through the combination with Nvidia, we're going to have a lot more resource to bear in creating an even richer portfolio of IP, of enabling that through the entire semiconductor industry and helping fuel the delivery of all these really cool applications that are to come.
You've never seen anything like it. And the reason for that is because we have two companies that are large and successful. And we're large and we're going to continue to be successful independently. However, the combination is so special because the two of us are complementary. The two of us don't do the same things, and nor do we do it in the same ways for the same markets. And ARM is a world-class CPU IP company and the most popular CPU core in the world. NVIDIA is a platform technology company. We're about the peripherals, the accelerated computing, the software stack. We're a platform company. And so when the two companies come together that are so complementary, and we do things that are so different, the combination is going to bring new ideas and new innovation to the market. Obviously, it's going to bring a lot more scale because the two companies together are just going to be a lot bigger. And the benefit to the market and to the ARM customers is going to be more IP, better IP, more accelerated roadmaps, and hopefully taking ARM to the far reaches of what is becoming what Simon just said, the diversity of computing that's literally going in every single direction. You're covering from cloud to edge to IoT to high performance computing to microprocessors to accelerated computing. I mean, everything. Because the breadth of computing today is just gigantic. And it was made possible by some of the dynamics we already talked about. And the way that people want to use computers is different. The way people want to design computers is different. And the thing that I really love, what ARM has enabled us to do is design specialized types of computers. And I happen to believe that this open way of allowing the industry, enabling the industry to create bespoke and different types of computers in this diverse world is exactly the way you want to go about it. Now, what we could do is just give it a whole bunch more speed and scale.
The first thing I thought about was competition. And it's so funny, and my company, we span the smartphone to the data center and everything in between. And my first thought was, boy, this is going to be great for competition. If I look at the PC market, if I look at the data center compute market, those markets need more competition.
When I think about the way the end market competes, it's about creating products, it's doing new things, it's innovating. And really, when I think about our business over the last 30 years, what we've done is create these building blocks that are really useful in all these chips, which saves people time. It saves people from having to reinvent the wheel. It means that they can apply their R&D resources on things which are really differentiating. And I think the more we can do that, the more we can put these tools in people's hands where they can then innovate around it, build on top, the better. So again, through this combination, we're going to create more stuff. We're going to be able to look at more markets at the same time, go deeper, go further up the stack, really understand the end applications through the work that Nvidia have done over the years, and create a richer portfolio of IP to companies who are then going to be in a better place to innovate on top of a bigger platform and create even more competitive products in the market. So I think this is only good for competition.
For the vast majority of people I've spoken to, the transaction is super welcome and they were super excited about it. One of the things that they love is the idea that NVIDIA's leadership in artificial intelligence and the software and the platform technologies could be brought out to the far edges of the markets where ARM is today. And ARM has great presence. That's where the IoT is going to happen. That's where the edge AI is going to happen. There's a lot of wonderful things that could happen out there, but the fundamental technologies of artificial intelligence aren't out there. And our combination, one obvious thing to do is to go do that, to bring NVIDIA's technology into the ARM ecosystem. However, there are a few people that have expressed that ARM is best for the ecosystem as an independent company, and equated independence with goodness. When ARM was focused largely on mobile and one particular industry, and at the nature of the development of the mobile industry at the time, it was a great situation. However, Simon and I both recognize that going into the future, independence doesn't equate to strength. Independence doesn't equate to vibrancy in the ecosystem. That in order to bring computing out to the edge and to the new places that we want to go, having a platform stack, having software capability, having understanding and reach into the ecosystem, working with the developers in the ecosystem, that capability is richly valued, and we have an opportunity to bring that together. And so I think there's a fallacy in equating independence with strength and vibrancy of ARM, which ultimately what the customers of ARM want. They want not just an open ARM, an independent ARM. What they want is a strong ARM, and a strong ARM that allows them to go into these wonderful new markets.
I think it really is important to look at the future when thinking about what we're going to be able to do, because the complexity of the systems that our licensees are building going up and up and up. Once upon a time, our roadmap was, we had ARM 7 and 9 and 11, and they were fundamentally designed around mobile. And if you had an application that kind of looked like that, we had a product for you. We were able to create a microcontroller family, relatively low cost investment for us, didn't need a big software stack around it. It's been massively successful. There's about 1 billion of them a month that get sold. But they're relatively simple devices in terms of the software and the complexity of everything that sits around them. Everything we were talking about at the beginning, way more complex. There's the software stack, the interaction between these components. It's a different world in the future than it has been in the past. And we need a different approach to go and address that and keep providing all these technologies that our licensees are asking for. Yeah. And that's what we're uniquely going to be able to do.
Yeah, I appreciate you addressing that, because there obviously are some people who are afraid that they'll be competing with Nvidia, who's very competitive and very successful after the close. And I think what you said, Jensen, addressed that. One thing I want to shift to, though, is UK is very proud to have ARM, and it should be. What type of investments are you going to jointly continue to make in the UK post-close? And how far does that commitment go out?
In the UK, in Cambridge, we have one of the world's premier microprocessor and IP development center. There are no equals. And it is one of the reasons why the CPU cores that have been made by ARM over the years have established itself in the way that it has. The development of IP that is configurable, that allows customers to use it in a variety of ways. It's on the one hand general purpose, but on the other hand, it's configurable for all the needs of the customers. That know-how is really quite difficult when you think about it in the context of computer architectures and optimized designs. And to be able to have, on the one hand, super optimized and super performant, energy efficient designs on the one hand, and have it be configurable and general purpose on the other hand, it's a tension that most engineers fail at, and somehow the ARM and the Cambridge ecosystem and the design center that's there has done it at a world-class level. We have every intention to not only continue to do it there, but to invest in doing it more there. There's something that is really special in Cambridge, and you guys know this. It is the birthplace of computers and genomics. And we have a lot of partners in the Cambridge area in the UK that is at the intersection of computational biology, computational genomics, and of course computer science. And our opportunity here with starting from that headquarters is to grow that headquarters, but also to bring Nvidia's ability to invest in AI research and robotics research and computational biology and all of the capabilities we have to help UK become a center of world-class AI development. I think we have something really special as a starting point. And I recently announced a supercomputer there, the largest supercomputer in the United Kingdom, called Cambridge 1. And the excitement is fantastic.
Did you talk about the investment level with that?
Cambridge 1, that supercomputing center, call it $100 million, just as a starting point. I mean, it's a big investment. It is the most powerful supercomputer in the UK, and researchers are super excited about it. So, anyways, I am so enamored with Cambridge and the engineering team there, and we have every intention to invest more.
So, export control has been a hot topic lately. Does anything change with the close?
No. I mean, export control is a function of where a product was created, the nationality of the people that worked on the product. It's got nothing to do with the nationality of the company that owns the product itself. So a lot of our products are developed in the UK. Most of our products are developed outside the US. US export control applies to some of our products, doesn't apply to a lot of our products. So nothing changes when the deal closes.
Let's talk about the data center. I love the data center. You all love the data center. How is this combination going to make ARM a bigger player in the data center?
The concept of a data center is a computer infrastructure that is secure, that is powerful, of course, and that has the ability to support multiple tenants running multiple things remotely. And so this data center could be a very large thing. It could be the size of a football field. It could be a supercomputing center the size of a basketball court. It could be an enterprise data center about twice the size of that. It could be a 5G base station. It could be a retail store. It could be a factory. It could be a broom closet. It could be all the way out on the edge on four wheels because it's inside a car. All of these computers in the future are going to be very data center-like. They're going to be secure. They're going to be cloud native. They're going to be multi-tenant. They're going to be able to run AI. You will manage these data centers from afar, and their data centers will come in all kinds of different sizes and shapes. The one thing for sure is we're going to try to make a contribution in servicing and enabling data centers all over the world. The applications are so diverse. The computing ecosystem is literally going in every direction at the same time because of the things we talked about. because of software-defined computing, because of cloud-native computing, because of the fact that we could wire things together wirelessly or over 5G, and very importantly, because of this new type of software development called AI. We can now put computers literally everywhere doing smart things, and we'll orchestrate it from one pane of glass, like your friend. And so I think that the high-level bit is that data center is going to be everywhere. They'll have some commonalities. They'll be secure, they'll be cloud-native, they'll be confidential, they'll be multi-tenant, they'll be AI-driven. Those are the commonalities. What's going to be different is the software stack that you run on top of it is going to be completely different. Some of it will run VMware, some of it will run Linux, some of it will run Kubernetes on Linux. And there are all kinds of different types of software stacks that you want to run. Some of it is monolithic, some of it is microservices and containers, some of it is disaggregated, some of it is not. And so all of these kinds of different architectures and implications on data centers is what really makes computing industry hard. Another Pat that we know, Gelsinger, who's one of the veterans of the computer industry, he said there's 1 trillion lines of code on the x86. It's not untrue. It's not untrue. There's 1 trillion lines of code in the x86. All the peripherals, all the software stack, all the middleware. That's one of the beauties of the x86. And so what Simon and I would like to do is there are some segments in the marketplace where ARM is really quite perfect. However, there's a lot of software to do, a lot of peripheral technology to bring to bear, and a lot of different system configurations to create, a lot of application developer ecosystem to go cultivate. And that journey will be long, but we're two companies with a lot of might.
So Simon, I have to ask, based on Jensen's definition of the data center, will there be more ARM in the data center?
That's the plan, for sure.
That's the plan. Indeed.
I mean, what Jensen just described was a massive diversity of what a data center is, requiring different solutions. And our business model is all about enabling people to build different solutions around common standards. So you get a lot of software reuse, and so it's easy to build optimized solutions for the kind of problem that you're looking to solve. But it's an enormous space. And it's going to take a long, long journey and a lot of investment to really fulfill on the potential that there is in the data center.
There's nothing more I would like to talk about products and opportunities, but I get a lot of questions from investors and talking to your customers, and digital sovereignty has come up, and sometimes they call it the balkanization between China, the US, Western Europe. What impact does this deal, how are you thinking about this digital sovereignty situation as it relates to the two of you coming together?
Well, frankly, this is exactly the reason why ARM is popular. ARM gives you the ability to build your own computer and by extension, build your own computer industry. However, building a vibrant computer industry takes more than ARM. It is the enabler, but it takes more than that. And so in the combination of our company, we'll be able to provide an open CPU ISA for license with all kinds of different sizes and shapes and scales. And together, we're going to build an ecosystem around the ARM CPU so that people all over the world could decide what kind of shapes and sizes of computers they would like to make. And I was giving a keynote recently, and I noted there are supercomputers in France being built with ARM, supercomputers in Japan being built with ARM, supercomputers in China being built with ARM. There's supercomputers in the United States. We're building one with ARM. We're building one in the UK with ARM. And so there's all kinds of different systems and sizes and architectures and that you could create because of the open licensing model, because of the openness of it.
I'm hopeful that we can work globally together, but it does sound like there's pockets of IP in different places that will continue to be the case. If a certain country needs its IP there, it'll be there, and vice versa.
And remember, you want open, but you want strong open.
Right.
Nobody wants to build a weak computer. Nobody wants to build an inadequate computer. In order to, you would like to have independence, but you would like to have strength with that independence. And so the thing that as Simon was saying earlier, the computer industry has changed shapes tremendously, and this is your observation as well. In the last 10, 20 years, the computer industry we're in today doesn't resemble anything that we came from.
Right.
And that's the beauty of it.
Yeah.
That's the exciting part of our industry. The open architecture and open licensing model is still incredibly valuable and more valuable today than before. However, a computer takes more than the CPU now because of all the things that we know about accelerated computing and AI and different types of computers that are all over the world, and how you manage it, how you orchestrate it, how you develop software for it is all completely different today than it used to be. And so between the two of us, we'll be able to provide the openness of a world-class CPU, the strength of a combined company that provides vibrancy and richness of solution and scale and speed of technology, which matters a tremendous amount, and very importantly, platform and software technology to create these markets and platforms for the world.
And what that does in doing that is actually drive down the cost of technology innovation, right? Because there's a bunch of cool stuff that we'll do, but no one can be expert in everything. So one thing I think our business generally has helped do is drive down the cost of innovation of anything requiring a microprocessor, because so much is kind of there and it works and it's great. Is there more we can do? Can we make it better? Of course. But it's allowed people to build on top. Again, spend their R&D on the things that are really differentiating, spend their R&D on new stuff, and not have to reinvent the wheel the whole time.
The nature of a platform.
Absolutely.
Right? Stand on the platform, build something more.
So the more we can do that, the stronger we can make it, the richer the IP set. We help fuel innovation, and that's a great thing globally.
Jensen, you brought up Grace recently. First Tera level chip was a combination of your machine learning technology, and you had a CPU in there as well. And I got a lot of questions on why do you have to buy ARM? Why don't you just license what they do? Here you have a CPU. You've achieved what you wanted to do.
We've been working with ARM for a long time, and we've been building SoCs for a long time. And in a lot of ways, Grace is just the world's largest ARM SoC. It's a gigantic SoC. And so it is absolutely true. We have a great working relationship with ARM already. We license the architecture. We don't have to buy ARM. Nvidia is doing well. Nvidia has a great strategy ahead. We don't have to buy ARM. We want to buy ARM. I want to buy ARM. This combination is going to be great for the ecosystem. It's going to expand the reach of NVIDIA's ecosystem, although these markets are rather new to us, mobile and embedded and others. These markets are going to benefit from AI. And I'm incredibly excited about sharing our technology in an area that we care very much about and very good at with 1 billion devices a day. And they're all going to be intelligent. They're all going to be smart chips that are out all over the world, trillions of devices connected to the internet. That opens that up for us. What we can bring to ARM is to complement their CPU core with the peripherals and the software stack and the system capabilities so that we can turn ARM into, in addition to great mobile processors, and continue to advance that and accelerate that roadmap, but to also extend the ARM CPU into computing worlds and computing markets that we're very good at, that otherwise would be too hard for them to reach independently. And so I think the combination brings innovation to our market. It brings innovation to ARM's market. It extends NVIDIA's capabilities to devices that otherwise are just nearly impossible for us to reach. And so I'm excited about that part of it.
We've really always had the ambition to be in every chip. A number of times over the years, people have said, "Hey, you've got all this cool stuff for mobile. Why don't you just build an SoC for mobile? And you could probably have, bigger revenues." You go, "Yeah, well, that's interesting, but it's
I may have been one of those people.
In fact, I think you have. But I'd like to be able to address every market, and the definition of every changes every day. And that's where we're really going to be. That will really change the game for Arm, because just like this explosion that's going on in the end markets, the number of opportunities growing and growing. The opportunity to address all of that, I think, is what uniquely comes from it. So, there are people that say, oh, you should stay independent. But I think this is a much better outcome because of just how the definition of everything is getting bigger and bigger and bigger. And I want to be able to address everything.
Yeah, everything about computing has changed in the last 10 years. The way we write software and the software we can write, we call artificial intelligence, and the applications you could use a computer for, and the way you design a computer, all three layers has fundamentally changed. It's really quite shocking. And there is no one business model that's perfect for everything. I love the idea that we could license an architecture to enable large industries, while in the select industries where we have specialty, that we create solutions for. Those are not competing ideas, they're complementary ideas. I also think that as a chip company, in the world of artificial intelligence, it makes no sense. There is no such thing as a chip artificial intelligence company. Artificial intelligence is about creating skills, software that has skills. In order for it to be an artificial intelligence company, you have to be rich with software, rich with AI algorithm capability, and as well as rich with semiconductor and processor design capability. That full stack approach I've always advocated as essential in this new world of computing. We would love to be able to refactor that capability and make available to licensees who would like to have it. And then lastly, the computer industry, because of the type of AI software we can now write, you could put smart cameras, smart microphones, smart thermal sensors, smart vibration sensors, smart wheels, smart everything, all over the world, connected by the internet. We're going to have computers literally everywhere, and that industry is brand new. And as Simon was saying earlier, customers and markets and applications that we haven't even conceived of. That's the beauty of the Arm business model.
Yeah, and that's actually what I'm most excited about. You've got two companies with their own unique superpowers with very little overlap and sometimes at different spectrums. And that's what I'm excited about, is to see what the two of you can bring out there. There's not enough competition in certain markets, and there's not enough capability in certain markets to really move the rock hard. But I really believe that the two of you can do this, and I cannot wait to see what's going to happen. And I just want to thank you for making day 3 a spectacular day with the two of you. So thank you very much.
Well, congratulations on your conference.
I appreciate that.
Fantastic work.
Thanks.
Thanks a lot, Pat.
So this is Pat Moorhead with More Insights and Strategy, signing out for day 3. If you're still hanging in there, we have a few more segments to go, but have a great day.